Here we go. All right, we're going to finish this up finally. I don't know, you can call that B, I guess. Is this, yeah, this is only the second day we've done this, right? So if you want to call it B, oops, I got to change my writing thing. Let's change this. Let's change this. All right, so if you want to make this a B, you can do that. All right, so here we go. We're going to go back to Algebra 1. You ready? So 5x equals 20. We kind of talked about this a little bit yesterday, but I'm going to talk about it again. All right, so 5x equals 20. What would you do? You divide by 5. Remember doing this yesterday? Okay, I said there's another way that you could look at it. Let's see. Did I do this? No, I didn't do this. All we did was find the inverse matrix, right? Wasn't that the last thing that we did? Okay, so we haven't solved for x and y yet, correct? All right, so I just want to make sure I'm in the right spot. Okay, so, but I did talk about this, though, yesterday. Instead of division, with matrices, you don't really divide. What do? You multiply by the... It's not negative. The inverse, the reciprocal. Right, you multiply by the reciprocal, or what word do we use dealing with matrices? Not reciprocal, but what? The inverse, okay? So watch. We could divide by 5, but in matrices, we don't really do division. Okay, you're the only one right now. So look, instead of dividing by 5, what can we do? We can multiply by the what? Yeah, let's use matrix words. I just said it 3 times. The inverse, okay? Multiply by the inverse. Would you agree that's the same thing as dividing? So if I want to get x by itself, if I want to get rid of something that's being multiplied by it, how do I get rid of something that's being multiplied? I multiply by the inverse. So I do it to both sides, and then, right, I can do this. So that goes, x equals, and then I just do that multiplication, correct? All right, and that's easy. That goes like this, and it's 4. Simple. With matrices, it's kind of the same idea, except we're not dividing. We're multiplying by the inverse, okay? And we learned yesterday, the very last thing that we did yesterday was learn how to figure out what the inverse was. The day before that, we learned how to multiply 2 matrices together. Agreed? Yes. So that's what we're going to do. And we're going to do that in order to solve a system of equations. All right? So we're going to, I think they only do 2 by 2s. They do. All right? So we're only going to do a 2 by 2 or a x and a y. Remember, before we did the matrix things, we did solve for, what do they call it, systems of equations with 2 variables. And then the next day we did solve equations, what did I call it? Systems of equations with what? 3 variables. All right. So we're only going to do the 2 variable thing right now. And that's really not that hard. I mean, I don't know if this is necessarily going to be easier than just doing it algebraically, but it's a different way to do it. All right. Some of you might like this way better. I don't know. I think it might be a little more involved, but let's just look at it. So it's 2x plus 3y equals negative 17. And then x minus y equals 4. So what we're going to do is we're going to solve this, but we're going to solve it with matrices, okay? Matrix multiplication, okay? Or matrix equations. So this thing right here is kind of set up as a matrix. Do you see it? I got the top left, I got the top right, I got the bottom left, and I got the bottom right. Everybody see that? But what we're going to do is we're not going to use the x's. We're just going to use the numbers. Some people like this better because it's not bogged down with all these variables. All right, so how do you think we're going to set up this 2 by 2 matrix? What's it going to be? Remember, we said, yeah, but the number, we're using these numbers.
2x, 2.
But we said we're not going to, listen to what I'm saying. Okay, we're not going to include,
Bless you.
How in the world can I teach in this situation? So look, we're not, I said just a second ago, we're not going to be using the variables. All right, we're going to knock the variables out. Okay, so what do you think we're going to put in place of this x? Because this is kind of like our x1 and x2. This is kind of like our y1 and our y2. All right, so I've got 2, and then over here I've got a 3. what's the variable, or what's the coefficient of this?
1.
It's a 1. So what am I going to put here? A 1. And what's the coefficient of the y? It's -1. Okay? Now, what's that 2 doing to the x? What's the 3 doing to the y? Multiplying. So what we're going to do is we're going to multiply it by x and y. No, not negative y, just a y. We already got the negative. We already got the negative right here with the -1. Okay? See what I'm doing? I'm just breaking this down without the x's and y's, and I'm breaking it down into matrices. And what we're going to do is we're going to solve for this matrix. All right, we're going to solve for x and y. So we got another matrix. What about these numbers right here? -17 and 4. Okay? Now, will this work? Will a 2 by 2 multiplied by a 1 by 2, will that, actually, sorry, it's not a 1 by 2, what is it? Rows, columns, right? How many rows? 2. How many columns? 1. Will those multiply to give you a 2 by 1? Okay, big question mark. Yeah, it will, because that right there tells you that you can multiply them together, okay? And this tells you what our final matrix is going to be. So that is correct. Everything's good so far, right? We haven't really done anything yet. All I've done was check to make sure that I can do this, okay? And the rules of multiplication apply and all that. So remember what we did with the 5x equals 20? Instead of dividing, look, we're not going to divide by this matrix, 2, 3, 1, -1. What are we going to do? We're going to multiply it by, waiting, we're going to multiply it by the, what? The inverse. We're going to multiply it by the inverse. So what happened when I multiplied this number by its inverse? They did what? What happened here? Not what we're going to do next. What happened here? They canceled out, right? Would you agree? Yeah, that's why we did it, right? So they cancel out. So guess what's going to happen here? If I multiply this by its inverse, what's going to happen? It's going to cancel out. Do I have to show it? Nah, it's too much work. Okay, finding the inverse is a little bit tedious. Okay, I am not going to show my work here. I know it's going to do what? It's going to cancel. All right. So what I'm left with is this. Now, somebody said it already. Whatever you do to one side, you got to do it to the other side. So if I took the inverse of this matrix on the left side, what do I have to do to the right side? Take the inverse matrix of the right side. Now, that's the last thing that we did yesterday. All right, do you remember how to find the inverse matrix? So I'm going to leave a big blank right there, and then I'm going to put, give me a sec. Okay, yeah. So watch, I'm going to put a big blank right there just because we're going to do some work in there, and then I'm going to say -17, 4. So this big blank is going to be my inverse matrix, right? So let's get rid of these things so we can see our numbers. Okay, so what we're going to do is we're going to take the inverse matrix of this. Do you remember how to do that? It starts off what? 1 over the, no, it's not the,
What is the word? Inverse. Oh,
the determinant. That's right. You go 1 over the determinant, okay? So I'm just going to write it. We'll do we'll actually do the work on the determinant in a second, all right? But that's not it though. That's not the inverse. It's that times what? No. I got to move. I got to give myself some more space. Right. This is one where you change the place of the 2 and then you change the signs of the 2. That's right. All right. So now you remember a little bit from yesterday, correct? And that's going to be a times right there. Remember, I probably made that too big, but what do we do with that 2, 3, -1 thing? What do we do? We change which ones? The 2 and the -1. We change the place of it. So instead of 2, see this 2 and -1 right here? We're going to put the -1 here and the what? The 2 down here. So that's how we find the inverse. And then what do we do with these two? Just change the signs. That's right. So you keep the number there, but you change the sign. Keep this number here, but you change the sign. Okay? So this whole thing right there is the what? No, just this little bit's the determinant. What's that whole thing that I circled? It's the inverse. It's the inverse of this. So what did I just do? Let's go back to the 5x equals 20. I multiplied this side by the 1/5, right? And so now I multiply this side by the what? The 1/5. But it's not 1/5, all right? It's the inverse matrix. It's a lot more complicated than just 1/5, but that's what it is. It's the inverse of this, okay? If I took the inverse of this side, it canceled it out, right? Now I'm taking the inverse times this. This is like my 1/5 times 20. That's basically what's going on here. Does that make sense to you? I'm just referring back to that very simple algebra equation. Okay, so now let's continue. Yeah, well, let's find the determinant, and then we're going to multiply that determinant by this. Remember, the determinant's going to be a scalar number. It's just going to be an actual number. It's not going to be a matrix. It just comes out to a number. Do you remember how to find the determinant? Okay, crisscross, if you want to call it that, cross multiply. But then what do? We multiply it, and then we subtract. That's right. So it's going to be 1 over. So we do this. 2 times -1 is -2. And then what do we do with this? Minus what? 3. All right? And what does that become? I'm not going to write all that stuff out. I'm just going to write this part. 1 over what? -5. Okay? So now it's 1 over -5 times this. Now this multiplication is pretty simple. All right? And then we're going to multiply that by -17. Oops, not over. What am I doing? 17/4. Okay? And what is this going to equal? This is going to equal x and y, isn't it? Okay? Showing every little step here, pretty much. You with me? So, what do we do here? -1/5. So we just multiply this -1/5 times this whole matrix right here. So we just multiply -1/5 times all 4 of these things. So what's that going to give us right up here? It's going to be +1/5 right here. And then let's go to the right. +3/5. Then this one, +1/5, right? And then this is going to be -2/5. Okay? And then we're going to take that and we're going to multiply it by this. Let me make sure I'm doing this right. Oh, you know what? No. Sorry. Just cross that out. Or erase it, whatever. There's a better way to do it. You could do it that way. But that's going to be a pain in the butt. I don't know why I did that. I just went off. Wasn't looking at my notes. I need to stick with my notes, all right? You could do it that way if you wanted to. But there's a better way. Because look, it's called the transitive property. Remember transitive? Okay, look. I could have done this, right? Everybody watching? I could have gone A times B and then multiplied by C, or I could have done what? Multiplied what? The B times C and then multiplied by the A. I don't know why I did it that way, but I think it might be easier to take these two matrices, multiply them together, and then at the very end, multiply it by the -1/5. Because if you do that, you're dealing with all these fractions in there, right? And you don't want to have to go through that mess. That's going to be ugly. So it's probably a lot better to multiply these together than multiply by -1/5. Okay? Sorry about that. So let's do that. So I still have that -1/5 out here. And let's figure out what it's going to be. We'll just put a bracket here. Remember how to do this? We go across here and down here. All right? You see that? All right, I'm going to get rid of those lines so we can see what we're doing. So what am I going to do? I'm going to go -1 times -17, which gives me 17. Okay? Then I'm going to go -3 times 17. No, I'm sorry. Then I'm going to go -3. Yeah. Wait a minute. Yeah, -3 times 4. I'm going to go across. Right, I went like this, and I went like this. Sorry. Oops. 17. I erased too much. All right, so we're going to go this, and then we're going to go this. Let's get rid of these circles. All right, so I went this and this, then I'm going to go this and this. Do you see it? Yep. All right, so we go the first one times the first one, the second one times the second one. All right, but then what do we... Yes, and so what do we get with that? We get a minus 12, correct? All right, and then what do? We do this times these. All right, so it's negative 1 times negative 17, which again is 17, and then 2 times 4, which is 8, plus 8. All right, and then we can just do that. So it's negative 1/5. Now it's clear sailing. It's kind of easy now. We will. This is one element. 17 minus 12 is going to be one number. All right, so we do get a 2 by 1. So 17 minus 12 is 5, and 17 plus 8 is 25. Do you see that? And we're almost done. Almost there. What's negative 1/5 times 5? Negative. Right. If you need to, do it down here like this, right? Everything cancels, but you got a negative, so what's going to be? Negative 1. Okay? And then what's negative 1/5 times 25? No. It's 25 over 5. Watch. It's negative 1/5 times 25. You see that? So that goes once, that goes 5. It's negative 5. So what did we just do right there? We found the determinant way back in the day. All right? Right, we found x and y. See, xy is equal to this. So look, so xy is equal to what? Negative 1, negative 5. So if you want to write it, x equals y equals, just say what? X equals negative 1, y equals negative 5. And that's another way, probably not the best way on this particular problem. But there might be some problems, okay? Especially when you start getting bigger matrices. When you start getting bigger matrices, this way tends to be a lot better of a way. All right, everybody listening, right? I don't have many eyeballs. Come on. I mean, I got 2, but I need 48 of them since there's 24 of you in here, okay? I need 48 eyeballs looking at me. So this is definitely not the most efficient way to solve this problem. All right? I'm not acting like it is. Just showing you, taking a fairly easy problem and showing you how you could do it with matrices. There will come a point, especially when you have more variables. There comes a point where it's a lot better using matrices than it is trying to do X and Y and substitution, elimination, and all that kind of stuff. Okay? You follow me on that? Yeah. So there are times where this is a better way to do it. Not in this particular problem, but we're just learning how to do it. That's all we're doing, okay? So there are times where it's a better way to do it. And there you go. So there was a couple times we stumbled, had to backtrack a little bit. But I think we went through it fairly reasonably good, all right? And just watch it again. Try it again. What I would do, if I were you, okay, before you even do a problem like this on the homework, I would do this exact problem. Look at your notes, try to figure out what you did, and then just try it from scratch. All right? That's the best way to do it, because at least you got your notes to fall back on, right? You get stuck on a spot, you're like, oh man, I forget what to do now. Look at your notes, like, oh yeah, okay, that's what we did, right? If you do that, it's going to help you do problems that you haven't seen before. Do the one that you're familiar with, because you'll have a tendency to remember what we did in class. And if you can do it by yourself with this, then you're ready to try the ones from the book. All right? Now, will anybody actually do that? I kind of doubt it. But at least that's my job, is to tell you how to approach this. All right? So I broke this up into 2 sections. So section 2.5a and It's pages. This is on your lesson plan, but I'm going to put it on here anyway. I think it is, isn't it? Did I put it in 2 parts? Okay. Yeah, we're like a day behind. So this was actually for Thursday. Today's Friday, so we're kind of a day behind. So on Monday we'll do the 2.5b, all right? But so today do 2.5a. On Monday we'll work on 2.5b. So the stuff that we just finished doing, I kind of doubt that it's in here. I don't know. I don't have the book in front of me, but I have a feeling that those that we just did are probably not part of 14 to 33. But it's a good warm up. And then on Monday, you might want to review the video again, and then you should be able to do the rest. I'll just show you what the rest. So 2.5b, I think I put that on the lesson plan thing because we were supposed to be doing this today, but we're a little behind, just a day behind. Yeah. All right, so this is the part B. If you get that done, you really want to go all out because you kind of got this already in your head and you want to try those. I have a feeling that these problems right here are the ones we just finished doing. All right, that's my guess. Again, I don't have the book in front of me, but you can look and see if it is. All right, everybody good? All right, you got a good 22 minutes to work on this. That's plenty of time to get started. All right, so let's not be like a little middle school kid and say, oh, we only got 20 minutes left. I'm not going to do anything. No, let's be good students. All right, let's be pre-calculus students. Let's be honor students and start on the work right now and get a lot of this done.